You think it's perfect? Of course not. There are some problems. One problem is, remember I told you that the way you do the dot product, since these are images, vectors, you can just line them up and multiply them. That was the dot product. That's how you take the dot product of these two 10,000 dimensional vectors. That should have made you wonder, well, what happens if it's misaligned, right? The eyes aren't exactly in the right place, okay? The scale is a little bit different. The answer is it doesn't work very well, right? It really requires good alignment, scaling. Also, the background has to be not too terrible. That can be done, but it is a sensitivity of the method. Another cute little story. At the time, they had these 8,000 faces, and they wanted to put them in a scaled, lined up way. And so you could imagine trying to write a computer program that would sort of find where the eyes were and then line them up. Or you could pay an undergraduate. So they paid an undergraduate to click on the pupils of the eyes of each picture of the 8,000 pictures. I think his first name was Wasi. I can't remember. If you're out there, my apologies. And what was great is, Sandy will tell you, is as the student was working on these 8,000 pictures, he came back and said, I have a new appreciation for what order of magnitude means. Because the difference between doing 80 pictures and 8,000 pictures, as you can imagine, took a long time. But you basically have to line this up. Now, you can use methods to automatically align the eyes, scale, etc., and then that kind of thing will work. Another limitation that is sort of a more theoretical basis for PCA in general, principal component analysis. Typically, the way you do it is you take your entire population, you find the direction of variance over the whole population, you project down along those dimensions, and then you try to discriminate between the different classes. In this data here, we have blue points and we have red points. But if the first thing you did was find the axis of elongation, okay, the axis along which there's the most variation, all right, and you projected these points down, well, clearly you will confuse the blue points and the red points, right? So it happens to be that the way of separating the classes, right, so the direction along which you want to separate the classes is not the direction along which all the points are distributed. There is methods in pattern recognition, Fisher analysis, linear discriminant analysis for using not just the structure of the population but the structure of the classes to determine which way to separate. We won't talk about them here because it's kind of an old method, but it actually talks more about the discriminative methods that we'll talk about not next time but the time after. The idea is saying that, well, I don't need so much to model the points themselves, because the points are elongated this way. I need to model the separation between the points. So a limitation of PCA is that sometimes the direction of maximum variance is not always the best direction to project on for doing classification.